Okay, so I wanted to kind of give a primer on the AI development lifecycle, sort of lessons learned, and some tips. And so let's dive right in. So I want to talk about what's different about AI development. So when we consider the nature of AI, we see that we give an AI prompts, and then it can generate code from that. This results in automated code generation. There's some other aspects of AI, such as the mirror effect, which means that the kind of language you use and the ideas that you give the AI are going to kind of be given back to you. And so this really has an impact on the quality of your ideas. And then also, an AI is sort of like a really brilliant amnesiac. And this is where like context management really plays a critical role. So some of the properties from this is that it's really efficient. One sentence can equal hundreds of lines of code. And it also allows for a high level of specificity. So when you think about the history of software, we went from binary, assembly, low-level languages, high-level languages, and now we're full circle at English. And basically, we're moving further and further away from machine-level instructions, right? So these abstractions are meant to sort of be reflective of our own mental models now. All right, so that means that we're going to give plain language to an AI system. It's going to produce code. What kind of plain language do we want to give? We want to give specs or specifications. And these specifications should outline the purpose of your system, the requirements, and the structure of your system. And some of the concerns that I frequently hear are things like, I'm concerned that it's not going to be a secure system, or I think it's going to be a low quality system. You see sort of memes like AI code slop. But sort of underneath these concerns, I think, are emotional reactions such as like job security and then also preference. If you're a developer, you spend a lot of time learning how to write code, the syntax, the frameworks, that years invested. And now with plain language, you can get structure and syntax and framework integration. And so I think there's just a little bit of like emotional reaction to AI development. But there are real security and quality concerns, which I will address in what's called the verifier system. There's another concern, which is how does AI impact people's mental acuity or prowess? Does it make people lazy AF? I just want to point out that it's not a necessity of AI. The AI doesn't make you dumb. In fact, people that can use it and leverage it well will actually get ahead, which is why I think that the market, like success, will correct sort of laziness. If you produce slop, people are going to quickly, like the proof is in the pudding, right? So people are not going to want to pay for that. This leads us to the idea that specs are a new all-important source of truth, and also this idea that we need to optimize for our feedback loops, meaning from the time that and I'll get into this in a second, but these are two really critical ideas that we're going to talk about today. And this means if you adopt a slow feedback loop, you're just not going to make it. So the goal then is to create tasteful specs and have a fast feedback loop or multiple fast feedback loops. All right, so the first feedback loop is spec development. This is where you kind of outline the justification for your system, the tech stack you want to use, the organization of your system and its composition. And then you're going to generate code based off that. You're going to evaluate the code, take a quick look at it, see how it's organized, find the areas that surprised you and the areas where the AI contributed something that needed to be in your spec, or it contributed something that you needed to create guardrails against because you didn't want that kind of result. And so you're going to create multiple specs, and I recommend trying different approaches. So In the past, you would, maybe design a system with one kind of architecture, and then you would refine it until it was really good. But now with AI development, this allows you to actually try out many different like architectures, different approaches, and using sort of good design taste, land on an architecture or an approach that that really meets the need of the system, of the business that you're building the system for. To learn more about spec development, there's a YouTube video called The New Code by Sean Grove. It was given at the AI Engineering World Fair that I was at earlier this year. Highly recommend this talk if you haven't watched it yet. All right, so that's the first feedback loop. And you want this feedback loop to be fast. And I'm just going to keep saying that over and over. Your feedback loops need to be really fast. You want to write some specs, generate, evaluate. Do it again and again and again as fast as possible. Okay, then we're going to move to the next feedback loop, which is the system plus verifier development. So here you can see that you are now moving on from spec development to prompt engineering, where you have some system that's been built on a spec that you like, but it's incomplete. There are issues with it. There are bugs. And so now you're going to do the refinement stage. And so you're going to write a prompt. You're going to generate some code. You're going to verify that the code, the system is doing now what you expect it to do, and make more prompt updates. And this happens in a cycle. So the important step here is this verify step. How do we know that the thing that we asked the AI for is the thing that we wanted? And that really means, like, what is the interface for you, the user, to use to verify this system? And you kind of have two main options. You have the web or browser and your terminal, right? Because we're really not interested so much in the code itself anymore. We're trying to get away from the code and get more at the sort of, you can think of it like throwing a baseball. You don't have to understand the physics of throwing a baseball to see if the baseball landed at the target destination, right? It doesn't really matter how it gets there. What matters is, did it get there in a way that was desired, right? Was it at the right speed? Did it hit the right target, right? And in a similar way, we want a verifier system that allows us to figure out, did the AI create a system that we want? And in the terminal, you can do things like unit tests, scripts, curl requests to kind of poke and prod this system to see if it's behaving in a good way. Another way is you can use a web app. So like Replit or Lovable does this, where they have prompts on the left and a browser on the right. And as you type prompts, you can see the changes happening to your application and use them. But for more complex systems that we would design, we need something a bit more sophisticated than just a browser. We need a verifier app. And this will help us do things like ensure that security requirements are met, that functional tests are met, and that compliance requirements are met. So this verifier web app acts as a test harness to determine if our system is behaving and exhibiting the behaviors that we expect from the system. What's cool about this is that we can build this test harness, this verifier, specifically for the system that we're building, right? So instead of a generic tool that meets all needs, all verification needs, we can develop a very specialized, specific tool that verifies exactly what this system needs to do. And so the goal of this second feedback loop, is to create a verified system, to explore design taste, and to have confidence that the system that you've created behaves and acts in the ways that you expect, right? So you can kind of think of the verifier app as like a higher level version of unit tests. All right, now finally we're going to end here with some tips. Use Markdown for your specs. Works well with AI and is also great for readability. Go from general to specific in terms of spec writing. Store your specs in /AI-specs to not confuse IDEs that these are not spec test files, but these are actually a form of documentation. Have a spec hierarchy, define the entire system, from a high level, and then define subsystems under that. Work on generating one system at a time. So once you enter in the second feedback loop of your actual system development, just kind of build one piece at a time and verify as you go. For example, I'm working on a big platform right now. The first system that I'm building is the verifier system. And then the first system I'm building is the platform system that manages all the services. It's sort of like infrastructure almost. And then the verifier system comes next. And then once I have the verifier system, I'll start building specific microservices and then using the verify system to validate and verify that these microservices behave the way that I want. Okay, Claude Code that uses Opus under the hood. They have in a claude.md file, which you can get when you open up Claude by typing /init. You can leverage what are called @mentions, so you can pull in your specs into the context window by default. This is different than the chat history that you're actually using in Claude. This is a context that Claude Code is managing independently of your chat session, which is why when you do /compress, you're not going to lose the context of these spec files. So they'll always be included in context. It saves you a lot of time. You don't have to constantly tell the AI, hey, remember my designs? Hey, remember my designs? Because remember, these are amnesiac systems. So you want to make sure that the spec context is always included. And that's the reason why I cannot recommend Codex, because it doesn't have this @mention support currently. But you can get, if you want to use GPT-5, ChatGPT-5, you can use Cursor, because Cursor has rules, and rules do support @mentions. In general, GPT-5 is faster than Opus, but it's also less agentic. So it's sort of a toss-up between like, Claude Code is going to move slowly, whereas Cursor is going to be faster, but Claude Code's going to ask for less, whereas Cursor is going to ask for more. So it's a question of like, what's your preference? And yeah, that should do it for this little quick explanation video on how to do spec-based development. And enjoy. Thanks, guys.